Session 4, Hypothesis Development and Testing. Introduction. Hypothesis, as noted in the previous study session, is a tentative statement relating to or more variables that you are interested in studying. This study session explains how hypothesis is developed in the research process. It will go further to expose you to how to test hypothesis and determine whether a hypothesis is accepted or rejected. At the end of this study session, you should be able to 1. Present an hypothesis relating one variable to the other. 2. Highlight the criteria for a good hypothesis. 3. Test an hypothesis. Developing an hypothesis. Developing your hypothesis should flow logically from the sources of information used to develop your research question. In other words, given what you already know from previous research, either your own or what you read in the journals, you should be able to make a tentative statement about how your variables of interest relate to one another. Hypothesis development is an important step in the research process because it will inform your later discussions concerning the variables to be manipulated and measured in your study. Because a poorly conceptualized research hypothesis may lead to invalid results, you have to take considerable care when stating your hypothesis. For example, imagine that your general research question centers on the relationship between aging and memory. You have spent several hours in the library using PSY info to find relevant research articles. You have found several articles showing that older adults show poorer memory performance on tasks such as learning nonsense syllables, learning lists of words, and recognizing pictures. However, you found very little on age differences in the ability to recall details of a complex event such as crime. Based on what you found about age differences in memory from your literature review, you strongly suspect that older adults would not recall the details of complex events as much as younger adults. Thus far, you have a general research question that centers on age differences in the ability to recall details of a complex event. Your next step is to translate your suspicion about the relationship between these two variables into a testable research hypothesis. You might, for example, develop the following hypothesis. Older adults are expected to recall fewer details of a complex event correctly than younger adults. In the example above, notice that you have taken the two variables from your general research question and have linked them with a specific statement concerning the expected relationship between them. This is the essence of distilling a general research question into a testable hypothesis. Once you have developed your hypothesis, your next task is to decide how to test it. Arriving at a hypothesis. There are some possible general sources of hypothesis. These include the following. Abstracting similarities. In these creative phases, the scientists may survey various data, abstract certain characteristics of those data, perceive some similarities in the abstractions, and relate those similarities to formulate a hypothesis. For instance, the psychologist largely observes stimulus and response events. It is noted that some stimuli are similar to other responses. Those stimuli that are perceived as similar according to a certain characteristic belong to the same class, and similarly for the responses. Forming analogies. Abstracting characteristics from one set of data and attempting to apply them to another phenomenon seems to be a form of reasoning, though through analogy. Indeed, careful investigations will very likely show that all philosophic theories are developed analogues. Dobbs, 1930. In support, he pointed out that John Locke's conception of simple and complex idea was probably suggested by the theory of chemical atoms and compounds that was becoming prominent in his day. Extrapolating from previous research. The hypotheses that you formulate are almost always dependent on the results of previous scientific inquiries. The findings from one experiment serve as stimuli to formulate new hypotheses. Although results from one experiment are used to test hypotheses, they can also suggest additional hypotheses. For example, if the result indicates that the hypothesis is false, they can possibly be used to form new hypothesis that is in accord with the experimental findings. In this case, the new hypothesis must be tested in a new experiment. Formulating a good hypothesis. The answer probably is that you learn this skill in the same manner that you learn everything else, by practice. Some hypotheses are obviously more difficult to formulate than others. Perhaps the more general a hypothesis is, the more difficult it is to conceive. The important general hypothesis must await the genius to proclaim them, at which time science makes a sizable spurt forward. To formulate useful and valuable hypotheses, a scientist needs, first, sufficient experience in the area, and second, the quality of genius, which includes the characteristics of perseverance. Once a hypothesis is formulated, it is tested, and certainly a confirmed hypothesis is better than a disconfirmed one, in that it solves a problem and thus provides some additional knowledge. But even so, some unconfirmed hypotheses are better than other confirmed hypotheses. Determining a good hypothesis. The following are criteria by which to judge hypothesis. Each criterion should be read with the understanding that the one that best satisfies it is the preferred hypothesis. Assuming that the hypothesis satisfies the other criteria equally well, it should also be understood that these are flexible criteria, offered tentatively. These criteria include the following. 1. That hypothesis must be testable. The hypothesis that is presently testable is superior to one that is only potentially testable. 2. That hypothesis should be in general harmony with other hypotheses in the field of investigation. Although this is not essential, the disharmonious hypothesis usually has a lower degree of probability. That hypothesis should be parsimonious. If two different hypotheses are advanced to solve a given problem, the more parsimonious one is to be preferred. 4. That hypothesis should have logical simplicity. This means logical unity and comprehensiveness, not ease of comprehension. Thus, if one hypothesis can account for a problem by itself, and another hypothesis can also account for the problem, but requires a number of supporting hypotheses or ad hoc assumptions, the former is to be preferred because of its greater logical simplicity. 5. That hypothesis should answer or be relevant to the particular problem addressed and not some other one. 6. That hypothesis should be expressed in a quantified form or be susceptible to convenient quantification. The hypothesis that is more highly quantified is to be preferred. 7. That hypothesis should have a large number of consequences and should be general in scope. The hypothesis that yields a large number of deductions, that is consequences, will explain more facts that are already established and will allow more predictions about events that are as yet unstudied or unestablished, some of which may be unexpected and novel. In general, the hypothesis that leads to the large number of important deductions will be the more fruitful hypothesis. However, what happens to a hypothesis that is disconfirmed? If there is a new, that is potentially better, hypothesis to take its place, it can be readily discarded. But if there is no new hypothesis, then you are likely to maintain the false hypothesis, at least temporarily. For no hypothesis ever seems to be finally discarded in science unless it is replaced by a new one. Hypothesis testing. Hypothesis testing consists of evaluating potential explanation for the observed relationships. In this study session, you will understand how hypothesis is tested and what confirms it. Testable explanation allows you to predict what relationship should and should not be observed if the explanation is correct. Hypothesis testing usually begins after you have collected enough information about the behavior to begin developing supportable explanations. Steps in testing an empirical hypothesis. Let us now summarize each major step that is involved in testing an empirical hypothesis. For this study session, you might design a study to compare the amount of anxiety experienced by students in different departments. The following steps are to be taken. State the problem. For example, is there a difference in anxiety levels among students of different departments? 2. State the hypothesis. For example, if the anxiety scores of English department and psychology department students are measured, the psychology department students will have the higher scores, or psychology department students will be higher in anxiety levels than English department students. 3. The experiment is designed. For example, anxiety is operationally defined, such as scores on the Taylor scale of manifested anxiety, Taylor, 1953. Then samples from each population are drawn, and so on. 4. The null hypothesis is stated. U1 minus U2 is equal to 0. There is no difference in the population means of the two groups. We are conducting a two-tailed test because we do not have sufficient reason to confidently predict that the psychology students will be more anxious. We just suspect from causal observation that they are. 5. A probability value for determining whether to reject the null hypothesis is established. For example, if P is less than 0.05, then the null hypothesis will be rejected. If P is greater than 0.05, the null hypothesis will not be rejected but accepted. Unless otherwise, it is assumed that you are conducting a two-tailed test, which is more conservative. 6. Collect the data and statistically analyze them. Compute the value of T for t-test and ascertain the corresponding critical value. 7. If the means are in the direction specified by the hypothesis, if the psychology students have a higher mean score than the English students, for example, and if the null hypothesis is rejected, it may be concluded that the hypothesis is confirmed. If the null hypothesis is not rejected, it may be concluded that the hypothesis is not confirmed. Or, if the null hypothesis is rejected, but the means are in the direction opposite to that predicted by the hypothesis, then the hypothesis is not confirmed. It is particularly important to distinguish causal from correlational relationship between variables. The relationship is causal, but if one variable directly influences the other. The relationship is correlational if the two variables simply change values together, that is, covary, and may or may not directly influence one another. Study session summary. In this study session, you observed that hypothesis development is an important step in the research process because it will drive your later discussions concerning the variables to be manipulated and measured in your study. Arriving at a hypothesis, one may abstract similarities to form and relate a stimulus class and a response class. You may reason, perhaps by analogy, and practice creating hypotheses. You may also rely heavily on findings from previous experiments to extrapolate potential answers to new problems. You learned that criteria for good hypotheses include that they are testable, are harmonious, that is compatible with other hypotheses, are parsimonious, or answer the problem addressed. Also, it is preferable that hypotheses have logical simplicity, are quantifiable, and are fruitful, so that they may yield numerous consequences. You use hypotheses to guide research and economize research efforts. But be aware of coincidence, for it may lead to something of importance that was not expected in the research. However, avoid experimental short-sightedness. You were also exposed to hypothesis testing so as to establish or check the adequacy of the proposed explanations. With this, we come to the end of study session 4. Thanks for listening.